Hey guys, this is the third lesson in our chemistry unit for Science 10. Just let you know, some of this is going to be review from Science 9, some of this is going to be new material. If you look on my Google Drive, beware the very last question on the assignment suffered from autocorrect, and so fluorine is misspelled. I'm so sorry, but it's a PDF and I wasn't able to fix it in time. So, Bohr models. I'm sure most of you are groaning at the thought of this because I know, at least if you had me last year, I tortured you with these. But to be able to do a Bohr model, first we have to remind you what the atomic structure is. So atomic structure is what an atom is made of. And there are three main parts: protons, neutrons, and electrons. Protons and neutrons are found in the nucleus. Electrons are found in the space around the nucleus. And we usually say that they're in shells. And there is a certain order to how we put these. 2 in the first shell, 8 in the second shell, and 8 in the third. And we generally don't go bigger than that. So, back to the three parts. Protons were positive. Neutrons are actually neutral. And electrons are negative. Okay, so to draw our Bohr diagrams, what we did was first, let's go over the atomic ones. So my favorite element, you guys may or may not remember, is oxygen. So when we look at the periodic table, we find out that the atomic number is 8. And that is actually the same as the number of protons. When we're talking about an atom, our number of protons is actually going to be the same as our electrons. So for this, it's going to have 8 electrons. Neutrons are a little bit harder. So neutrons are going to equal the atomic mass minus the number of protons. So remember, the mass is the number at the bottom, and it's usually the biggest number on the square in the periodic table. So for this one, the mass for oxygen is 16. The number of protons we have up here is 8. 16 minus 8 gives us 8 neutrons. So, the first thing we do when we draw a Bohr model is we draw our nucleus. And in our nucleus, we have to say what is in our nucleus. Well, we have 8 protons, and we have 8 neutrons. So P plus and N0. This is our lazy way of writing this, just like E minus is our lazy way to write electrons. Now that we have the nucleus filled in, we have to figure out how many electrons. Well, we know it's 8, but now we have to figure out how many shells. So the first shell can only fit 2. So we can only have 2 on there. Well, we have 8 in total, so once we take away 2, how many are we left with? 6. Well, that's less than the 8 that will fit on the second shell, which means we only need the 2 shells. Now this is where I get really picky. How we do this is we do pairs, but we can't pair them up right away because they only pair up after we go around once. So we go 1, and I'm going to number it so that you guys know what I'm doing. 2, 3, 4. Now we can start pairing. 5 and 6. So if I had 7 and 8, I'd put 7 down here and 8 over here. We can't pair them up right away because right now it's showing us that we have these 2 electrons that are all by themselves. And that's really important when we start looking at compounds. So if we do oxygen again, but we do it as an ion, remember an ion means that there's an uneven amount of protons and electrons, which means there's a charge. So again, the first thing we have to do is figure out how many protons, neutrons, and electrons there are. Well, an ion and an atom are similar in most ways. So it has the same number of protons, it has the same number of neutrons. The only difference is the number of electrons. And what you're actually going to do is you're going to do the number of protons minus the charge. So in this case, for oxygen, we know that we have 8 protons and we're doing minus, and what is the charge? So if you look in the top right corner of your of the square on the periodic table, it shows you that the charge is -2 for oxygen. So 8 minus -2. Well, a negative gives you a positive. So we actually have 10 electrons for the ion. We only had 8 last time. So again, we do our nucleus. We write what's in the nucleus. And now we start filling in our electrons. Well, in the first shell, again, we can still only fit 2. But 10 minus 2, that leaves us with 8. And even when we have 8, I tend to go 1, 2, 3, 4, 5, 6, 7, and 8. But there's a problem. We have 8 protons and 10 electrons, which means we have a charge. And we have a charge of -2. We can't just leave this ion like this without acknowledging the fact that there is a charge. So to do that, what we do is we put square brackets around it, and we write the charge in the top right corner. So 2 minus. Okay, so that's the review. Now I'm going to show you a much easier method. So now what we're going to be looking at is Lewis dot diagrams. And the cool thing about Lewis dot diagrams is that it gives you very similar information, but in way less work. So for oxygen, what we do for a Lewis dot diagram is we put the symbol, and then we put the electrons from the valence shell, and only the valence shell. Do you guys remember what the valence shell is? It's the outermost shell. Okay, so for oxygen, if we're looking first at the atom, how many electrons were in the outer shell? Well, if we scroll up, how many did we have in this outer shell? We had 1, 2, 3, 4, 5, 6. We had 6. So around this diagram, we are going to be putting 6 dots. But again, we put this in a very specific way. we have 1, 2, 3, 4, 5. And typically if we have pairs, we try and put them on the top and the bottom. It just makes it look neater and makes it easier for us to deal with. But that's all it is. Symbol and the outer electrons. So that's for an atom. But what about an ion? Well, we're going to do the same thing, the symbol. And then we're going to do the outermost electrons for that shell. And in this case, we had 8. And then we're going to do square brackets and our -2 to show that we have a charge. Not so bad, huh? Well, let's kick it up a notch. Let's do some compounds. So there are 2 major types of compounds that we look at, ionic and covalent. As you should be finished your naming, you'll remember that this is nonmetals. And these guys share electrons. This, it usually contains a metal. And gives or takes electrons. So if you were in my class last year, I made you actually do Bohr model compounds. This semester, I'm not making you do that, but you will have to do Lewis dot compounds. So if you're going to be doing a compound, an ionic compound to begin with, if we had something like NaCl, the first thing we do is we look at our sodium, which is our first element. So Na, how many electrons are in the outer shell? Well, remember there's a trick to this. If you look at what column it's in, so Na is in the first column, group 1, which was the alkali metals, they only have 1 electron in the outer shell. That entire column, all of them only have 1 electron. So we have 1 dot. Our chlorine, if you look, it's going to be in group 17. And in group 17, all of the elements in that column have 7 electrons in the outer shell. Well, this is an ionic compound because we know this because this is a metal. Na is a metal. So this is going to give and take, which means this electron here is actually going to be given to that element there. So we'll end up with Na with no electrons around it. And because there's no electrons around it and it's lost 1 electron, it has a charge of +1. Our Cl now has how many electrons around it? Well, it's gained 1 electron. So now it has 8. But again, it has a charge because it's gained an electron. And because it's gained a negative, it's going to have a charge of -1. So this is what the compound looks like using Lewis dot diagrams. Covalent, though, is a little bit different. So if we had CO2, which is carbon dioxide, we know that carbon has 4 electrons on the outside. We know this because it is in the 14th column. And oxygen, not only have we already done this, but we know that there are 6 electrons on the outside. But don't forget, I have 2 oxygens here. So what's going to happen is these lone electrons that are all by themselves, they are going to be shared. This carbon is going to share with each of these oxygens. So this is going to be shared, this is going to be shared, this is going to be shared, and this is going to be shared. And to show that we're sharing, we're actually going to replace these dots with lines. So each pair of electrons that are being shared is represented by one of these lines. At the same time, we can't forget about these guys, which is why you see me putting them on the top and the bottom of the oxygen. So if you remember, we also have diatomic molecules. And these were 7 very special ones. They form the shape of a 7 on a periodic table. And they are hydrogen, oxygen, chlorine, bromine, iodine, fluorine, and nitrogen. So these elements are so reactive that they are never found apart. They're always found together. So you'll never find just a plain hydrogen by itself in nature. If you find one, you'll always find it as a pair. Same with oxygen, chlorine, bromine, iodine, fluorine, and nitrogen. The thing about these are they're all nonmetals, which means they all have they have covalent bonds. So say we have hydrogen. Well, if you look, hydrogen has how many electrons in its outer shell? Well, it's in the first column. It actually does have 1 in the outer shell. Because they're both considered, well, hydrogen's considered a nonmetal and they'll share, what will happen is we actually have to draw the line. So it is like this. A lot of these are only sharing 1 pair of electrons, but there are ones that are sharing more. So oxygen, we know that oxygen has 6 in its outer shell, which means it has to share 2 pairs. And don't forget the other electrons that are on the outer shell, because you can't forget those. They don't disappear, they stay there. So that one shares 2, so it's called a double bond, because there are 2 pairs of shared electrons in between them. And nitrogen is even crazier. So if you look at nitrogen, it's in the 15th group, which means there's 5 electrons in the outer shell, which means I have 3 lone electrons that need bonds, which means how many pairs am I going to share? 1, 2, 3. If I'm sharing 3 pairs, how many lines am I going to have in between them? That's right, 3. 1, woo. 1, 2, 3. And then don't forget that one set of pair of electrons that are on each of the nitrogens. So today's assignment is the Lewis diagram worksheet. It is only one page, one side. I'm hoping it won't take you guys all that long. I hope you guys have a great weekend, and I'll be back on Monday going over balancing equations, which is just like solving puzzles. I think it's really fun. Hopefully you guys will too.